So chemical properties of alkalis. Alkalis, one most important chemical property in your IGCSE and GCO levels. This is very common a question because it is a sort of awareness for the society. You'll find out how. The idea is ammonium nitrate, suppose it is any ammonium compound. It may be ammonium chloride, ammonium sulfate, ammonium carbonate, ammonium hydroxide, ammonium nitrate. When they find any alkali as a reactant, any alkali or a weak base, weak alkali or a base, okay, like it can be even calcium hydroxide, weak alkali or a strong alkali, and when simply they are warm with it or kept in sun, a chemical reaction takes place. Ammonium compound reacts with alkali and produce ammonia, the gas, and byproducts are salt and water. So always this can be used as a test for an ammonium compound, or you want to test for the presence of ammonium ion in a compound, a substance X. Somebody claims it is an ammonium compound, fine, okay, add the substance X with what? With an alkali and heat a bit. You will find out a gas coming out with a pungent smell, and insert a moist litmus paper. It will turn what? From red to blue. It can be a test for an ammonium compound, or if sometime it can be a test for an alkali. Somebody says it's a transparent chemical is an alkali, okay, you want to test it's an alkali, add an ammonium compound together, heat a bit, wet red litmus paper at the mouth of the test tube, the gas comes out, pungent smell, or already an indication for ammonium compound, for ammonia gas, plus the moist litmus paper, okay, red litmus paper, it turns what? Blue, okay. So this is a very important reaction, no doubt, for testing alkalis, for testing ammonium ion, ammonium the cation, the presence of this cation in the salt can be tested by this test, react with alkali. Whenever in your assignment it's an ammonium compound in an alkali, alarm, it is a reaction, it will yield ammonia gas, okay. It's a test for the presence of ammonium ion, it's a confirmation for the presence of ammonium ion, because ammonium ion normally when you add it gives no precipitate, like calcium may give white precipitate, or zinc gives white precipitate, and iron give green precipitate, iron 2 with alkali. But when it is ammonium, no PPT, but test is what? Warm a bit, you'll find out the pungent smell, and the litmus paper from moist, if it is moist, from red to blue, it turns out, confirming the presence of ammonium ion. But I said farmers' mistake because this was a common norm around the world, especially Europe, that their soils get acidic. Excessive use of fertilizers, soils get acidic, and they used to neutralize the soil by adding the slaked lime, calcium hydroxide, or lime. Basically lime they used to add, calcium oxide. With water it turns calcium hydroxide, and it's a weak alkali, no doubt, very good method, provide hydroxyl ion in a controlled amount, and those hydroxyl ion will neutralize hydrogen ion, the acid, and produce what? Water. That was fine, but the mistake was they used to save some labor and time, they used to mix lime, calcium hydroxide, the slaked lime, okay, basically they mix calcium oxide, that turns into lime, that turns into slaked lime, and the soil has water. So they used to mix lime and ammonium fertilizer like urea together to save labor and time, but hardly they know at that time that that was counterproductive, because their fertilizer was being wasted, because the lime, calcium hydroxide, slaked lime, and ammonium fertilizer, ammonium sulfate or ammonium nitrate or ammonium carbonate, basically will react with each other in the warmth of the sun and produce ammonia gas. So the gas oozes out and nitrogen content of the soil decreases rather than increasing. So fertilizer was wasted, the most important nutrient nitrogen was not provided, depletion was already there, and fertilizer was also counterproductive because it has been wasted by a reaction. Acidity was also not tackled well by the calcium hydroxide that is busy reacting with this. So for universal mistake it was. So examiner, you will find out often asking this question just to spread the awareness, okay. So that is the reaction of alkalis with ammonium compound, and the farmer mistake, okay. Another use of alkali is famous. We use this word, alkalis are used in making soaps and detergents and stuff. And you know that alkalis are used in making soaps and detergents and cleaning agent around the world. They are the cleaning party. They are the cleaners, alkalis. Because alkalis, even the shampoos and other detergents and your body wash or your cleaning clothes, mean alkalis are involved. But alkali is not directly the alkali is used. Alkali is basically reacting with the oil or a fat. Okay, and it turns out to be a sodium salt of fatty acid. So soap is also salt. Okay, has alkaline in nature. Soapy touch alkalis also has. So that's why some excessive alkalis, if they are in the soaps, they cause corrosion, corrosiveness and all that. But soaps are also formed from alkalis by a reaction. You need not to know chemical equation at this stage, but you should be knowing that alkalis are reacted with soaps even from ancient times with oils and fats, and they turn into what? Soap. Sponification is the process. So very useful thing, the alkalis, and the bases, weak alkalis or bases basically are also used as antacids to kill the acidity of the soil, to kill the acidity of lakes, and primarily in digestion you have acidity. If it is the cause, then alkalis are used, weak alkalis, and in toothpaste they are used, okay, to neutralize the stuff. So acids and alkalis.